In this video, I will give a brief introduction to non-parametric tests. Parametric versus non-parametric tests. In a previous video, I have used an example where we looked at hours spent studying each week, and we saw that these data were normally distributed where the mean and the median and the mode were equal, around 10 hours. So if the data are normally distributed, you can use the mean as a measure of central tendency. And this is where you then use parametric tests if you want to do statistical tests. The parametric tests are based on the mean. On the other hand, you have non-parametric tests. I have also used this example in a previous video, the length of stay at a hospital ward. And here you can see that the mean is much higher than the median and the mode because we have some outliers. So when the data are not normally distributed, the median or the mode is the better measure of central tendency. And this is where we will use non-parametric tests, because these tests are based on the ranked data and not on the data themselves. I will now briefly go through two examples, one of a Mann-Whitney U test and the Wilcoxon signed rank test. The Mann-Whitney U test. If you have a dependent variable which is continuous, which you will find here in this table, and this variable is not normally distributed, then you will have to look in this column. And you have an independent variable which is categorical with two groups, and you have two different samples. This is where you will look. Then you will find that you can use the Mann-Whitney U test. The Mann-Whitney U test is the non-parametric equivalent to the two-sample t-test. So let's look at an example. The same with the length of stay. Is there a difference in length of stay in ward A and in ward B? The dependent variable is the length of stay, which is continuous, but now this one is not normally distributed. The independent variable is the patients from ward A and patients from ward B, or the two groups which are independent. So then you can do a Mann-Whitney U tests. I will not go into details about how to do a Mann-Whitney U tests, but what you should know is that this test is done on the rank of the observations of the length of stay rather than on the length of stay observations themselves. And now the Wilcoxon signed rank test. If you have a dependent variable which is continuous and it's not normally distributed, you look in this column, and the independent variable is categorical with two groups, but now this is a paired sample. Then you will look here and you can find the Wilcoxon signed rank test. This test is the non-parametric equivalent to the paired sample t-test. So if I have an example here, is there a difference in blood pressure before and after 12 weeks of treatment with medication X? I have used this example previously with the paired t-test, which is the parametric alternative. I have a group of people, I measure the blood pressure, and I give them this medication for 12 weeks, and then I measure the blood pressure again on the same group of people. The dependent variable is blood pressure, which is continuous, but now this is not normally distributed because I have very few observations in this example. The independent variable, that's the two samples from the same group of people, the patients before and the same patients after the treatment. So the Wilcoxon signed rank test is then done on the rank of the observations of blood pressure rather than on the blood pressure observations themselves. This was a very brief introduction to non-parametric tests. I refer you to other videos in order to find out how you can do these different non-parametric tests.